Can a massive MySQL data import on an SSD damage it? I have to import quite a lot of data, 100 million rows, 100 times, into a MySQL database. Currently, it is stored on my hard disk drive, and the bottleneck of my import seems to be the hard disk drive write speed. I have heard that SSDs do not like massive continuous writes, and that it tends to damage them. What do you think? Is this really an issue on modern SSDs?
It really is not a straightforward answer to this. SSDs do not care about continuous writes as much as how many times any particular sector is overwritten. When SSDs first came out, something like SQL was a bad word as the operating system in general treated the drive like a traditional HDD and failures were very frequent. Since then, drives have become bigger, cheaper, more reliable, meant for more read/writes, and the operating systems have become smarter. SSDs in SQL is not only common, but often encouraged. Feel free to peruse the DBA sister site. My thoughts are to do it, assuming the SQL server is built properly with redundant disks. If not, then expect a failure eventually anyway.
Reads are fine, and SSDs can have their bits read from without any detrimental effect. Writes are another matter. Clearing a bit affects the integrity of the bit, and after a lot of sequential writes, the bit will stop accepting new writes altogether. It can, however, still be read. Let me just say that the write limits on new enterprise drives are huge. Take Samsung's new 845 DC Pro. It is good for 10 drive writes per day for 5 years on warranty. I would imagine it will do twice that number. To put that into numbers, that's 14,600 and NBSB TB written over 5 years on the 800 and NBSB GB model. Or 2,920 and NBSB TB per year. Or 8 and NBSB TB per day for 5 years. Show me a hard drive with a warranty that covers that much use. I'm not even sure you could write 8 and NBSB TB to a HDD in a day. 50 and NBSB MB/S average throughput 60 and NBSB seconds, 60 and NBSB minutes, 24 and NBSB hours equals 4,320,000 and NBSB MB/day equals 4.32 and NBSB TB/day. It turns out you can't, on an average drive. As long as you use a drive like this, based on VNAND, or equally durable SLC, not one based on TLC or bad MLC flash, you should be fine. And anyway, RAID and backups are your friend for a reason. And at least if the SSD write limit does become an issue, you can still read the data stored in the faulty bits. SSDs are also cheaper to run, cooler, quieter, and enterprise models are especially resistant to power issues. No more head crash fears, and of course, a huge performance increase for your database access needs.
Writing to SSDs isn't necessarily bad. It's the writing and rewriting of a single block that's bad. Meaning if you write a file, delete it, then write it again, or make small amounts of changes to a file over and over again. This causes wear on the SSDs. Databases would definitely fit into this category. However, according to this article, petabytes of data have been written to SSDs and still been operable. This is probably due to advances to wear leveling. Wear leveling attempts to work around these limitations by arranging data so that erasures and rewrites are distributed evenly across the medium. In this way, no single erase block prematurely fails due to a high concentration of write cycles. In your particular situation, I would have the databases reside on the SSD for speed, but backed up on a daily basis. You also might consider getting 2 SSDs in a RAID and NBSV, one array as well. The likelihood of 2 SSDs failing at the same time is low. Note: RAID arrays are not backups. No matter if you use a RAID array or not, have a backup. No matter if you use an SSD or not, have a backup.
Let's assume your import involves no updates and no deletions. So you are doing all insertions. This should only be writing new data to the transaction log. This means as data is added, it is always being written to a new sector. There might be some buffer/swap that gets churned/written to multiple times, but ignoring that, all of those inserts would theoretically result in no more than one write per sector. Depending on how MySQL is implemented, and what kind of bulk insert you are performing, you might generate a second set of writes later when the transaction log is integrated into the main data file. I'm going off an understanding of different DB engines, and assuming MySQL is somewhat similar in how transaction logs are flushed. Point being, you are not churning the SSD. That is, you are not doing a great deal of modifications/moves/deletions/etc. That would potentially rewrite over the same sectors many times. So you are essentially only going to generate a very small number of writes per sector, and that's what really matters. Assuming you are not completely filling up the SSD, there should be sufficient free space for those hotspots such as buffers/swap, which are being churned to minimize wear-through wear leveling algorithms. Indexes might be another matter, as clustered indexes in many DBS involve a lot of modifications as data is inserted. Usually when doing large inserts in a data warehouse environment, you turn off indexes during bulk import, then update them after.
If you want to support the channel, please consider subscribing.